So we need a definition, and this is out of
C groups
15.1.
of pi things.
And this is just an expansion of a definition you already know. So the word I want to define is critical point. Yeah, we're going to start doing optimization. So what's a critical point from Calc 1? Yeah, it's going to be maybe, right? A potential max. That's where f prime is 0, right?
Yeah.
Or
Maximum.
or undefined. Why is it important to do undefined?
Because that's where all the weird stuff happens.
Yeah, maybe the like absolute value function, right? I want these critical points to have all my maxes and mins in there, right? So I would like for this thing, absolute value of x, right? I'd like to find that minimum with whatever process I'm doing. So I should throw the undefined things in there so that I can capture those minimums. Does that kind of make sense? So we're going to do the exact same thing in Calc 3, except that we now have new derivatives, right?
Yeah.
Okay, so what are your new derivatives?
Partial.
Yeah, there's a partial with respect to x and a partial with respect to y.
Partial. Well, no, Z.
Do I have an easy way to, let me see, or undefined? How about that? Start with that. R. Critical points. You just fill in the rest of my sentence here. What's a good way to encapsulate all of the partials at once without messing around?
Flat.
Close. The directional derivative, right, would be a good start.
Equals 0.
So I could set the directional derivative equal to 0, but I mean in all the directions, right? Yeah, so how do I get a directional derivative?
Gradient.
Yeah, dot product with the gradient, right?
Yeah.
So let me just set the gradient equal to 0.
Gradient equals the 0 vector.
Oh, yeah.
Okay, so what do I need to finish this sentence off? Like subject and a verb, right?
Oh. When the gradient is.
When, yeah.
Oh, I have a verb, R.
Yeah.
Points where, right, gradient of f is 0, or, what do I mean undefined? Or,
When f prime is on.
yeah, or when, really, f prime, right?
Yeah.
And in this case, I mean the gradient, right?
Yeah.
So, points where the gradient of f is 0 or the gradient of f is undefined are critical points. Does that jive with my thought of f prime is 0 or undefined? Yeah, same thing. Cool? Alright, this is really what there is. Keep in mind that the whole gradient vector has to be 0. You want a quick example?
Yeah.
Easy one we already know. How about if f of x and y is our favorite x squared plus y squared? Right? Our very favorite, what is this freaking thing?
Radius
Squared.
Yeah, this is the radius squared function, so this is the,
It's the fair. It's the cone.
Oh, the elliptical.
Or not the cone, that's the bowl.
yeah, this is the circular bowl, right? This is a circular paraboloid. Point it out. But this is my new age, right, Calc 3 version of x squared. Right? It's the one I'm going to check everything with because it's like the simplest and non-linear function. Okay, so what's the gradient of f in this one?
2xi plus 2yj.
Perfect. Okay, so if it's 2xi plus 2yj, what would you say here, right?
At 0, 0.
Okay, so that's better than what I was expecting. What I was expecting was, okay, x is 0 or y is 0, right?
Yeah.
So like both have to be 0.
Yeah, I don't mean or, right? I mean, they both have to be 0, right? Both the I component and the j component have to be 0.
Yeah.
You see that? So both partial derivatives have to simultaneously be 0. Cool. So the only point I get here is 0, 0. Is that a max or a min?
We don't.
We don't know.
You do know.
Oh,
Well,
here
it's a
it is.
min,
It's a min.
but
It's a min.
Yeah, it's a min, right? Because
Trying
it's a
to-
bowl.
Yeah.
I know what
Like
this
cool.
shape looks like.
There's a negative outcome and be a max.
So 0, 0 is a min on this one. And I know that because I have a geometric reason to think that, right? Or, because when I plug 0, 0 in, what do I get out of this function?
You're just gonna get 0 back here.
0, right?
It can never be negative because they're both squared.
Yeah, and then I'm squaring two things, adding them together. 0 is the smallest they can be, so this is definitely a min. For a geometric reason. Cool? So for right now, that's how we're going to do optimization, is by geometry. Cool?